There's a 15-minute window after a nuclear detonation that almost nobody talks about. And it's not the fireball, it's not the shockwave, and it's not even the immediate radiation burst that kills most people in the fallout zone. It's what happens in those first 15 minutes after the bomb goes off, when the sky is still glowing and you're standing there trying to figure out what just happened that determines whether you live or die. And here's the thing nobody tells you. Most people waste those 15 minutes doing exactly the wrong thing. Let's start with what actually happens when a nuclear weapon detonates, because if you don't understand the physics, you won't understand why that 15-minute window exists in the first place. When a nuke goes off, you get three immediate threats: the thermal pulse, the blast wave, and the prompt radiation. The thermal pulse is the flash of heat and light that can set fires miles away and cause third-degree burns to exposed skin. The blast wave follows seconds later, a wall of compressed air moving faster than the speed of sound that levels buildings and turns windows into thousands of flying razors. And the prompt radiation is a burst of gamma rays and neutrons that cook anything living within about a mile of ground zero. If you're close enough to experience these effects directly, you're probably already dead or dying, so we're not talking about you. We're talking about everyone else, the people who are far enough away to survive the initial detonation, but close enough to be in serious danger from what comes next. What comes next is fallout, and this is where that 15-minute window becomes critical. Fallout is radioactive debris, the vaporized remains of the bomb itself, the soil and buildings it pulverized, and everything else that got sucked up into that iconic mushroom cloud. This material gets lifted high into the atmosphere, sometimes tens of thousands of feet up, and then it starts to fall back down. The heaviest particles, the ones carrying the most intense radiation, start hitting the ground within 15 to 30 minutes of the detonation. The lighter particles can stay airborne for hours, drifting with the wind and coming down slowly over a much wider area. But that first wave, that initial dump of the hottest, most dangerous fallout, that's what you need to avoid. And the only way to avoid it is to get inside, get deep, and get protected before it starts raining down on you. Here's what most people get wrong. They see the flash, they feel the shockwave, and their first instinct is to run. They want to get as far away from ground zero as possible, which makes sense on an emotional level, but is catastrophically wrong from a survival standpoint. If you're outside when that fallout starts coming down, you're getting a lethal dose of radiation whether you're running or standing still. The particles settle on your skin, your clothes, your hair, you breathe them in. They stick to your shoes and you track them everywhere you go. And because you're moving, you're breathing harder, pulling more contaminated air into your lungs. Every minute you spend outside after fallout starts descending is a minute closer to acute radiation syndrome. And by the time you realize you've made a mistake, it's too late to undo the damage. So, what should you do instead? The answer is brutally simple. Get inside immediately, get as much mass between you and the outside world as possible, and stay there. Forget about running. Forget about trying to get home if you're somewhere else. Forget about checking on family members or grabbing supplies from your car. The only thing that matters in those first 15 minutes is finding shelter and getting underground or behind thick walls. The best shelter is a basement, especially if it's in the middle of a large building with multiple floors above you. Every floor between you and the roof is another layer of protection, another barrier between you and the gamma rays streaming off those fallout particles. If you're in a single-story building with no basement, get to the center of the structure away from windows and exterior walls. Use furniture, books, bags of soil, anything dense and heavy to create a barrier around you. Concrete is better than wood, brick is better than drywall, steel is better than nothing. The reason this works comes down to the physics of radiation shielding. Gamma rays, the most penetrating form of radiation you're dealing with in fallout, lose energy as they pass through matter. The denser the matter, the more energy they lose. Lead is ideal because it's incredibly dense, which is why you see it used in medical X-ray rooms, but you probably don't have lead walls in your house. What you do have is a whole lot of other materials that, while less effective than lead, still provide meaningful protection when stacked up. A foot of concrete reduces gamma radiation by about 90%. 2 feet reduces it by 99%. 3 feet and you're down to less than 1% of the original dose getting through. The same principle applies to dirt, which is why being underground is so effective. 3 feet of packed earth provides roughly the same protection as 1 foot of concrete. This is why fallout shelters are typically underground and why your basement is your best friend in a nuclear event. But here's the catch, and this is where people make their second fatal mistake. You need to get to that shelter before the fallout arrives, which means you have somewhere between 10 and 20 minutes depending on wind speed, altitude of the burst, and your distance from ground zero. If the bomb was an airburst designed to maximize blast damage over a wide area, the fallout will be less intense but spread over a larger region. If it was a ground burst, which is more likely if the target was a hardened facility like a missile silo or command bunker, the fallout will be much heavier and more localized. Either way, you're on a countdown from the moment you see that flash. Every second you spend dithering, every moment you waste trying to decide what to do is a second closer to those particles starting to drift down around you. By the time you see dust settling, by the time you notice a fine grit accumulating on surfaces, you're already in trouble. So let's walk through this step by step, because knowing what to do is useless if you can't execute it under pressure. You see a bright flash, brighter than anything you've ever seen, bright enough to leave after images if you're not looking directly at it. If you're indoors, stay there. If you're outdoors, you have seconds, maybe a minute at most, to get inside the nearest sturdy building before the blast wave hits. The blast wave will arrive faster if you're close to ground zero, slower if you're farther away. But it's coming. When it hits, it'll sound like the end of the world, a roar so loud you'll feel it in your chest, and the air pressure will spike hard enough to burst eardrums if you're unlucky. Buildings will shake, windows will shatter, doors will blow open or slam shut. Ride it out, keep your head down, protect your ears and eyes, and wait for the shaking to stop. Once the blast wave passes, you have your 15-minute window. This is when you move, fast and decisively. If you're not already in a basement, get to one. If there is no basement, get to the center of the building, away from exterior walls and windows. If you're in a car, abandon it and get inside a structure. Cars provide almost no radiation shielding. The metal might stop alpha and beta particles, but it does nothing against gamma rays, and the windows are useless. If you're in a high-rise, do not go to the upper floors. The top of a tall building is one of the worst places to be during fallout because there's nothing between you and the sky, nothing to absorb the radiation raining down. Get to the lowest floor possible, ideally the basement or parking garage. If you have to choose between a basement in a small building and the ground floor of a large building with multiple floors above you, take the large building. More floors means more mass overhead, more protection. Now, here's something critical that gets left out of most fallout advice. You need to seal yourself in, but you also need to be able to breathe. Fallout particles are fine like dust, and they can get sucked into a building through ventilation systems, gaps around doors and windows, even tiny cracks in walls. Your goal is to create a positive pressure environment where air is flowing out, not in, or at least to minimize air exchange with the outside world. Turn off HVAC systems if you can. Stuff towels or duct tape around doors and windows. If you have plastic sheeting, use it to seal off your shelter space from the rest of the building. But do not seal yourself in so completely that you suffocate. You need airflow, just not airflow that's pulling in contaminated air from outside. This is a balancing act, and honestly, it's one of the trickier parts of fallout survival because you're trying to protect yourself from invisible particles while also not turning your shelter into a tomb. Water is your next concern, and this is where the 15-minute rule starts to matter in a different way. If you have access to water before the fallout arrives, fill every container you can find: bathtubs, sinks, pots, bottles, anything that holds liquid. Once fallout starts settling, any water that's exposed to the outside is potentially contaminated. Rainwater collection systems, outdoor wells, even municipal water supplies if the treatment plants are damaged or the intake pipes are exposed. The water you collect before fallout hits is safe water, water that hasn't been exposed to radioactive particles. The water you collect after is a gamble, and depending on how contaminated it is, it might kill you slower than thirst would, but it'll still kill you. This is also true for food. Anything that was outside when the fallout came down is contaminated. Anything that was sealed in a building or covered might be okay depending on how much fallout got inside. This is why preppers talk about stockpiling food and water, because in a nuclear event, resupply is not an option for days or weeks. Let's talk about time now, because the nature of radioactive decay means that fallout becomes less dangerous the longer you wait. The rule of sevens is a useful guideline here. For every seven-fold increase in time after the detonation, the radiation level drops by a factor of 10. So 7 hours after the blast, radiation is down to about 10% of what it was at 1 hour. 49 hours, roughly 2 days, and it's down to 1% of what it was. 2 weeks, and it's dropped to 1/10 of 1%. This doesn't mean it's safe to go outside after 2 weeks, but it does mean that the acute danger, the immediate life-threatening doses, decay relatively quickly. The problem is that you have to survive those first 2 weeks, and that means staying in your shelter, minimizing exposure, and rationing your supplies.